All right, let's talk about optimization problems. And I think, personally, I think optimization problems are pretty nifty because, well, mainly they're practicality. They're just really practical. You can use math to help make decisions as far as what's what's the minimum required, material that I have to use for this, or what's the maximum volume. It allows math to model real life situations and then use derivatives to figure out or to answer problems about those specific situations. So they're pretty neat, but they do take a little bit to get used to. So let's take a look at an example. Now, what we're doing here, just to review, is we're gonna find some equation that models a specific scenario in real life, and then we're gonna take the derivative of that, and we're gonna see where the derivative crosses zero, and then that's gonna tell us wherever this graph or this original function is going to be either at a peak or at a valley, depending on what we're looking at. So let's look at a problem. This one is actually from the textbook. This is problem number 21. So let's say you're out in a boat, and there's our boat right there. That's like a sail. There we go. So there's our boat, and this boat, actually, it wouldn't have a sail, I guess. I think we're in a rowboat, but I think that'll get the point across. All right. So, and then here's a restaurant right here. So this is where we are headed, and I want to row this boat a specific distance to the shore. We'll just kind of draw it like that. All right. So my boat is 4 miles out, and the total distance from here to the restaurant is going to be 6 miles. All right, so also I can walk. So I walk at 3 miles per hour, and I can row at 2 miles per hour. So the question is, what distance here, we'll call it x. What distance x do I have to row to that is going to make the time that it takes for me to row to shore and walk to the restaurant the absolute smallest? How can I do that the most efficiently? All right, well, so let's start using some math. We'll call this L right here. All right, so I know that my total distance, that is going to equal L plus whatever this is right here. Now this one is actually pretty easy to figure out. If this is 6 miles and this is x, this is just going to be 6 minus x. And then that'll give me this distance. So let me go ahead and write this. All right. Now, also, another thing that I can figure out is I know the distance, or this length L, because of the Pythagorean theorem. Right? So it's going to be the square root of 4 squared plus x squared. And we don't know what x is. That's what we're ultimately trying to solve for and to figure out. Okay, so I know that my total distance is going to be the square root. 4 squared is 16 plus x squared plus 6 minus x. Okay, now let's just say that we know these numbers, right? Let's say we know that this is, a certain amount of miles and this is a certain amount of miles. Well, if I take whatever that distance is and divide it by miles per hour, then that's going to give me the total time in hours. So like if this is scratch paper over here, right, and if I have miles divided by miles per hour, well, that's miles over 1 times hours over mile. So my miles cancel out, and that gives me hours. So I know that if I divide these distances by the rate that I can walk, then that's going to end up being this time, which is what I'm interested in. Also, again, just kind of think of it practically. If I'm going, 80 miles and I'm doing it at 20 miles an hour, to figure out the time, I'd do 80 divided by 20. Right? So that's the same kind of thing that we're doing here. So let's go ahead and we know our total distance. So let's put, then our total time is going to equal, okay, so this length L is my rowing, so that's 2. And then this other one, this 6 minus x, that's going to be my walking. So I'm going to divide that by 3. Okay, so we know we have a derivative for the time, which is what we're interested in. What's the shortest amount of time? So now let's just take this derivative with respect to x of this thing. So let me, real fast, I'm going to rewrite this as 1/2 times 16 plus x squared. So the 1/2 plus 1/3 times 6 minus x. And the reason I did that is anytime you have a constant, you can just not really worry about it with the derivative. So there is my derivative equation. Let's have at it. So, I'm running out of space. For just a second, I'm going to scroll down here so that we can keep going. Okay, so let's see here. So we have a composite function. So first I've got to take, the 1/2 stays the same. So I've got to take the derivative, we'll call this u. So if this is u, I'm going to have 1/2 times 16 plus x squared to the negative 1/2 times the derivative of the inside, which is just 2x. All right, so that's the first part. Then the second one, I've got plus 1/3. The derivative of this is just -1. So the derivative of 6 is 0. So all right, so there we have that one. All right, so let's simplify this a little bit. So this is going to equal, I've got 2x on the top, and then on the bottom I've got 4 times the square root of 16 plus x squared minus 1/3. Okay, one more simplification here. I'm just gonna, the 2 and the 4 simplify to 1/2. Okay, so voila, there we go. This is something, we're not gonna combine the 2 into 1 because we're at a spot that we can start working with this a little bit easier. Because remember, I want to set it equal to 0, or I want to find out when this equals 0. So let me go ahead and add 1/3 to each side. So I know that on this side I've got x over 2 square root of 16 plus x squared. I subtract, or I add 1/3 to each side. So that just equals 1/3. Whoops. Sorry, everyone. Here, you know what? We're kind of getting low on this paper. Let me tear this out real fast, and then I will recopy our equation over here. So I've got x over 2 square root of 16 plus x squared equals 1/3. Okay, there we go. Now we can keep going with our math here. All right, so remember we're solving for x. So let's go ahead and cross multiply to get rid of this stuff. Or I guess we could really, instead of cross multiplying, let's just multiply both sides by 3. So I'm gonna get, 3 up here goes to, oh, actually, never mind, scratch that. Yeah, let's cross multiply real fast. So I'm gonna get 3x equals 2 square root of 16 plus x squared. All right, and let's see. Well, let's square both sides now. This is going to be a good time to square both sides so I can get rid of that. So that's going to give me, ooh, that looks a little fuzzy. There we go. So on this side, I'm going to get 9x squared. And on this side, I'm going to get 4 times 16 plus x squared. All right. So let's go ahead and multiply. Oh, yeah, actually, hang on. That's equal sign right there. Okay. So let's go ahead and figure out what this is. So this side, 9x squared, stays the same. So I've got 4 times 16, that's 64. Plus 4x squared. All right, we're getting there, slowly but surely. Let's subtract 4x from each side. So that's going to give me 5x squared equals 64. Then I'm going to divide 5 by each side by 5. X squared equals 64 over 5. Then last step, I'm going to take the square root of both sides. So I get x equals the square root of 64 over the square root of 5. Square root of 64 is 8. Square root of 5 is the square root of 5. Woo! Voila! All right, that took a little while for us to do, but that's okay. Taking a while is fine. So I know that the distance that I want to, let's figure out what that is, just kind of not square root. So 8 divided by the square root of 5. So that's, I want to row 3.5, about 3.58 miles. So if I look back to this, right, I know that this is going to be about 3.58 right here. And then if I walk there, that's going to result in the time that is the least. Now, real fast, let's just take a second to verify this graphically, because that's the one, well, not the one, but that's just a few of the nice things that we can do. So let me find this, our equation here for our derivative. So there we go. I've got x divided by 2 times the square root. Where's that square root button? There it is. Square root of 16 plus x squared minus 1/3. Here, let me zoom the fit here. There we go, a little bit better. Look. Here, I'll get the, I wonder what happens if I do equals y. There we go. All right. There we go. So there, 3.58. That's the derivative. And then just for fun, let's put our first equation, the total distance equation. So that's going to be the square root of 16 plus x squared divided by 2 plus, plus 6 minus x divided by 3. All right, let's see where that is. There we go. And we can see right here that this minimum at 3.57, right where this crosses 0, is going to give me the lowest. Right after this, you know, I wonder what happens if I zoom it. Right after this, you see that it starts going up. So this means that this is your graph of time. So your time is going to increase. Your total time will increase after you hit this point right here, which we found with the derivative.